Hello, hello, and welcome to Chapter 4, which is all about functions. And today we are doing lesson 4.1, which is all about talking about graphing functions. So we're going to talk about kind of the basics of graphing functions and how to read these graphs as well. So our objectives are I can match simple graphs with situations, and I can graph a relationship. So we're going to start off right away in an example, and these are a little bit more like talkative kind of things than, working out math problems. It's a lot of analyzing and interpreting what is going on. So let's go ahead and read this first one. It says that relating graphs to situations. So it says the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents the situation. So we are given graph A, we're given graph B, and we're given graph C. Now, from my just looking at it, for the most part, I see that they're all going up and then they're all going back down. So they say, step 1, read the graph from left to right to show time passing. So just like I said, they're going up and it's going back down. It's going up, staying, going back down. Going up, going down. Step 2 is list keywords in order to decide what graph shows them. So, some words to be cautious about on how they phrase things is was constant. If it means it was constant, you're going to have a line that was horizontal. So in this case, they're showing that they say that graph A as well as graph B talk about that. And I can see that right here on my graphs because there's a horizontal line. Rose sharply means it's going to go upward, slanting upward, which also shows in graph A and B. Why are we not talking about C? There is an upward part, and maybe because it's steadily? Yeah, it should be C as well. So seeing that increase over here, I'm seeing increases in C as well. All right, stays the same. Again, that's the same thing as horizontal. I see that also in A. And drops sharply, or a downward sharp. B, I see that in A. I also even see that in C. So then they say pick the graph that shows all the key phrases in order. So let's read it again. It says the air temperature was constant for several hours. So we want something that was constant, so that starts off in a horizontal, which is actually going to be either graph A or B. So at this point, I think that's maybe why they put C out of the business. For several hours at the beginning of the day, and then rose steadily for several hours. A does that next, so does B, so I can't decide quite yet. Then it says it stayed the same temperature for most of the day before dropping sharply at sundown. Ooh. A does not show that it stayed the same or keeping that horizontal, but B does, and I think that's why they didn't put it here, since stay the same at that temperature. And so right now it's looking to be B, and then at the end of the day it dropped sharply downward, just like that. So looking at that, using these kind of phrases, horizontal, slanted upward, horizontal, slanted downward, your correct graph for picking for your solution would be graph B, as we were talking about. So it's a lot of decoding your words as well as taking it kind of step by step. Sorry, the sun is getting in the way. So now that we know, kind of looking at an example of how to describe a situation like this, we can talk about things like continuous and discrete graphs. So it says, as seen in example 1, some graphs are continuous lines or curves called continuous graphs. So all of these graphs that we were just looking at are considered to be continuous. They're going to show me everything in quadrant 1. They're going to keep going. Doesn't matter if it's curving, it's straight. It's just going to keep the line. But some graphs are only distinct points, and these are called discrete graphs. So here's an example of a discrete graph then. It's got some points. It says the graph on theme park attendance, and it is an example of discrete graph. It consists of distinct points because each year is a distinct and people are counted in whole numbers only. The values between the whole numbers are not included, so they have no meaning to the situation. So we're not talking in between years, and we're not talking about half a people or a quarter of a person. And so that's why it's considered distinct. There's distinct points on this graph that it's going to have. So again, continuous is going to show an actual line. Distinct is going to have some points. So let's take a look at some distinct graphs. So this one says sketching graphs from a situation. So a lot of these also already have these answers in here, and that's okay. A lot of it is more so talking through it and understanding what's going on in these problems. So it says sketch a graph for each situation. Tell whether the graph is continuous or discrete. So this first situation says Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. Well, obviously, if he's selling one, he's going to get $2.50. If he sells two, he's going to get 2 times that amount. 2.5 times 2 is $5. You know, if he sells 10, it's going to be $25. So that's what they're showing in this graph. They make a point at each one. Okay, this is how much money he'd make after 2, 3, so on, how many candles. It says the amount earned, or y-axis, increases by 2.50 for each candle Simon sells. So this is his x-axis. Something else as we get into graphs, we're going to be really focused on making sure we label our stuff. So if you notice, there's a title. It says Simon's earnings. The x-axis is also labeled, telling me that this is the amount of candles he's sold. And the y is telling me the amount of money that he earned. Okay? Since Simon can only sell whole numbers of candles, the graph is distinct at this point. He's not going to sell half a candle to someone. What are you going to do? Cut it in half? I just envision like the glass candles. Like, how are you? That makes no sense. So let's look at another situation here. So this one says that Angelique, that's a cool name. Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. Then she begins to run. Her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. As time passes during her workout, moving left to right along the x-axis, her heart rate is the y-axis, does the following. So it's kind of hard to see, but it should be kind of color-coded here. But they're showing you what each kind of phrase is within here. So this would be considered a continuous graph because guess what? Your heart rate's not going to stop unless obviously there's something wrong. So your heart rate's going to continue whether it's going up or down, and it's not going to be discrete. It's going to be considered continuous because it's not going to stop. It's just going to change directions or, change how fast or how, slow it's going. So they're talking about the red is talking about it remains the same. So I'm seeing that right here as well as right here. Rises at a steady increase, that's about here. Decreases more rapidly. Previous segment remains high. That's also kind of something I'm seeing up here. and he slows down and then returns back to normal. So it's showing me she started here, goes up, over, stays for a bit, and comes down, but then kind of stays out at the same heart rate measurement. So this one would be considered, like I said, a continuous graph. I think there's a couple more things. Oh, and this is part that I did mention, but it says, when sketching or interpreting a graph, pay close attention to the labels on each axis. Both graphs below show a relationship about a child going down a slide. Graph A represents child's distance from the ground above time. So it's talking about how far away from the ground it is over the time. So basically it's kind of showing me like the shape of the slide. But graph B is representing the child's speed over time. So remember, speed is how fast you're going, and so obviously at the 0 time they're not going fast, but as they keep going through time they're speeding up and then they slowly start slowing down. So the last one is looking at a graph and coming up with a situation that you could possibly see for this graph. So it says, write a possible situation from the given graph. So step 1 is identify your labels. So I notice that the X is time and my Y is water level. So I need something that's going to relate to that. Step 2 then is analyze my sections over time. So it looks like I have an increasing part, it remains the same, and then it decreases. So one situation that I'm looking at, even before reading what the textbook says, is I'm thinking water level, I'm thinking time. Maybe you decide you want to take a bath, and so, or you're gonna wash your dog. This happens when you have to like you're gonna fill up the tub. So as over time you're gonna add the water level to the tub. Then you're gonna turn it off. You're gonna let it sit there for a while. Maybe you're taking the bath. Maybe you're washing your dog. Okay, and then when you're done, you are going to pull the plug and the water is going to go down the drain and out of the tub. Here's what they said. They said a watering can is filled with water. It sits for a while until some flowers are planted. The water is then emptied on top of the planted flowers. So that's another type of situation that could happen. So in a case where you're given a graph and you're asked to create a situation, you know, there's multiple different types of situations, but as long as it makes sense with that graph. So obviously you had to be talking about something with water level and something about time, and talking about how it was increased in the amount of water, stayed the same, and then decreased. But your situations could be a little different. You know what? Maybe instead of, you know, watering, you know, flowers or filling up a tub, maybe you are, what else could you do? Yeah, I feel like watering is good. I can't think of anywhere else. Maybe someone else has a good idea. Maybe we can discuss this as a group if anyone else has another idea that would work for this. So that's the end of this video though. So I will have some time for you guys to work here in class, and just let me know your questions. So see you then.